So in the previous class we were discussing about methods of irrigation. So we had stopped at drip irrigation. We haven't discussed the drip irrigation. So let us just quickly understand this drip irrigation method. You might have already knew about drip irrigation, those who are acquainted with the agricultural thing. So drip irrigation is the most modern technique of applying water to your irrigation fields. So earlier drip irrigation used to be very costly business, right? So farmers didn't adapt to this kind of new technology. As the improvisation took place in this method, or whatever the requirements are there, like whatever the investment has to be done, when it is brought down or some subsidies given by the government, this method become a more usable method of irrigation. Okay, but it has its own limitation with respect to the kind of crops which can be grown from this method. Okay, so what basically this method is also called as a trickle irrigation. What happens is you do not apply water where it is not necessary. Like for example, the water is necessary exactly at the root zone. So you can see in this figure, so if you apply somewhere here the water, if it is applied away from the plant, it will be not any use, it gets evaporated. So it will be considered as a loss for irrigation supply, right? So if you apply water exactly above the root zone, so you can see this is the this is the area which is covered under the root zone. So if at all we have to apply water, we have to apply water here itself, so that the water penetrates here and reaches to the root zone. Like this we improve the efficiency by reducing all the other losses like evaporation losses and losses that are applied away by applying away from the root zone. So here we'll try to understand how it is being done. If you can see this, this is the small patch of land. This is a patch of land, and here is the trees which are grown. Okay, so to supply water to all these plantation, what we do is that first of all we should have a irrigation reservoir. Irrigation reservoir in the sense, you can if you go to any of the irrigation fields towards India or any other area, Indi Taluk and other areas, you will find out that there are huge large ponds are constructed, and you can see those ponds by which is covered by a plastic cover. They want to store the water. So basically what they do is that they lift the water from their borewells, or if they have a water course, like for example if there is a nala or a river stream, anything, they lift the water from that river or a nala or a borewell, and they store it in a huge surface water tank, and which is not of permanent in nature. It is done by earthen dam, and a plastic cover is applied. Okay, so such kind of storage tanks will be there. From the storage tank, the pump will lift the water, and it will what it basically does is that there are several filters are there. So basically because the water that you lifted, you have stored it for a long time in this pond, and you can say that the water may get polluted, and it may have a contaminant, or it may be having a suspended solid like leaves or anything. So what you do is that to remove all those plastic leaves on the top, there will be a screening, then there will be pressure tank and pressure filters. So you might have studied what are pressure filters. So these the water is supplied through these pressure filters. Then there is a basin which is which will help you apply the fertilizer. Okay, so whatever the water is flowing here, it will be added with the fertilizer from this tank. Then again one more screening will be there. So after this the water is supplied. Now you can see this is the main line from which the water is being supplied. From this again there are three branch lines which are going and which are perpendicular to this main line. Okay, then each branch line will have again perpendicular laterals. Okay, like this the laterals are there. So like this, a network has been generated, or a setup has been generated, and from this the water is supplied to the plants. Okay, now you can see the discharge can be managed from this wall, and also the discharges are managed from the branch pipes. Okay, so you don't have to reach to each and every plant to control the discharge. Like for example, if I want to supply only to these three rows, if I want to supply water to only these three rows, what I do is that I try to control it from here. Okay, similarly, if I have to supply only for these 3 rows, what I do is I shut down the walls from here and I operate for this only. So basically farmer decides how to supply water, what is the duration to be supplied water, so all of that will be decided. Okay, so this is what the drip irrigation is. So once we have discussed all the surface irrigation methods, we'll discuss about sprinkler irrigation method. So what happens in sprinkler irrigation? It is like creating an artificial rainfall. So you might have seen in several movies or in picture, you might have seen that how this network is generated. Okay, basically what we have is a reservoir similar to the reservoir I explained earlier. Then there will be a pumping machine. So this pumping machine will have a delivery pipe, and this delivery pipe, now right now what you see is that it is a pipeline that are laid laterally, okay, like this. So what happens is all these will have nozzles. Okay, so these nozzles are made to discharge on either side. Okay, on either side means parallel. What it happens is that the water goes perpendicular to the direction of the pipe which is been laid. If this is the direction of pipe which is been laid, the water will flow on the either side, as you can see in this picture. So what a farmer does is that, or the engineer does is that, he tries to understand how much is the pressure that is required at every wall. Okay, he designs this pump station, and he designs the wall in such a way that he maintains the pressure at all these different points. He measures what is the pressure that is required at all these different points. Based on that, the nozzle opening is being done, and all these nozzles will discharge same amount of water, though the pressure may vary from each nozzle, but the discharge should remain same. Like that, the nozzles are designed. Okay, and it is also taken care that whatever the gap between the two pipes are there, these are the two pipes, the gap that is there, and in this gap the cultivation is being made, and the discharge that is coming out from both the nozzle will cover this entire strip. Okay, like, what are the reasons that we supply water like this? If we are growing a very thick plantations, like for example, if you go for coffee or tea plantation, you will see that you do not have a chance to move into that thick plantation. It will be difficult for you to go every time and supply the discharge. If there is any problem, you may not reach every time in that plantation. It will be difficult for you. So in that case, what they do is that they put a sprinkler like this. So the sprinkler acts like a artificial rainfall, and you can basically understand that when you are supplying water, you will see the terrain condition also. Like, imagine if the terrain condition is completely slopy. In those areas, if you supply water at the root, or if you supply water from the soil itself on the surface, what will happen? The water will flow with respect to the gravity, and the water will not penetrate into the root zone. And there are some plants which require water from the top itself as a natural rainfall. So when you supply water on the top of the tree, the water will slowly penetrate into the root zone. Okay, like this, the sprinkler irrigation can be adopted. And as we know, there are disadvantages of sprinkler irrigation. The disadvantage is being the heavy initial investment that is to be done, or the capital that is to be invested in the prior. Okay, so after sprinkler irrigation, let us discuss about lift irrigation. I told you that there are perennial irrigation, or you can say it as gravity irrigation, which is also called as flow irrigation. Then we have lift irrigation. So in lift irrigation, what happens? You lift the water and you supply it to your fields. Okay, so like this, if there is a river or a stream, this is the pumping house. From this, the water is being taken. There is an intake or any structure is constructed. The water is lifted from here, and it is supplied to a overhead water tank in the farm field, and from the farm field the water has been supplied. This is what lift irrigation is. Okay, so in flow irrigation, what we do is that we make the water to flow with a gravity force, right? So here in lift irrigation, what we do, if there is a farmland, we lift directly water from the river. Okay, so when you go for flow irrigation, you need to construct huge dams, then several hydraulic structures, then there should be a canal network. Like this, you try to improvise your flow irrigation, right? So in case of lift irrigation, these are all the necessities. What an individual farmer does is that he directly puts a pump and construct a small intake structure near the river if he has a river. So near the river he'll construct a intake structure, and then he'll lift the water. Now the problem with the lift irrigation is that lift irrigation is very efficient for micro irrigation. Means if there is a small area of land that is to be irrigated, it will be more efficient. But when you go for larger area, flow irrigation becomes necessity. Okay, like this you can see there are some of the advantages and disadvantages which have been listed here. Okay, right. Now we have studied all the methods of irrigation, which means like the methods that are adopted by the farmers to apply water to their fields. Now as a civil engineer, we must be interested to know how do we supply water to the farmer, or to the dead end of the farm. Okay, after that the farmer will decide how to apply the water, whether you want to go for free flooding, check flooding, border flooding, strip flooding, or you will use the drip irrigation sprinkler method. So our job is to supply water till the end of his farm. Okay, right. So what are the types that we adopt? One is direct irrigation or diversion scheme. Then we have storage irrigation or storage scheme. Then we have combined diversion and storage scheme. Okay, like the name itself explains you what this basically is. In direct irrigation, there is no storage of water is being done. What they do is that they construct a barrier or they construct a weir. So you might have seen several barrages or weirs when you cross across any main road. Okay, so you might have seen those weirs. What happens is the weir, there is actually a barrier which is constructed, the water is flowing on the top of that barrier also. That is what weir is. Okay, so here we are not stopping the water to flow into the river, we are not completely stopping it. What we're doing is we are detaining some amount of water to some level. Okay, and the detention is decided based on the demand of the nearby villages. Okay, so for example, if there are around 10 villages or something, we'll construct a barrage with respect to the requirement of those 10 villages and the farmers of that 10 villages itself. In this, there is no storage being done. Whatever the water is there which is flowing in the rainfall period, we'll try to divert it to the farm fields. Okay, so this is what direct irrigation or diversion scheme. Now coming to storage scheme or storage irrigation. So what happens here is that you can see the example is simple, Almaty Dam. So in Almaty Dam, what we do is that we construct a huge barrier and we store water from water that is flowing for entire rainy season. We do not allow any water to flow in the downstream side, and there is a maximum capacity. After that, if the discharge is going to be more than that maximum capacity, we will discharge it to the downstream side. But what our aim is to store as much as water that is possible. So this is what been done in storage irrigation. Then the water is stored in the upstream side, as you can see in the Almaty Dam. It will be used for the entire year. The water may be supplied for industrial requirement, the water may be supplied for irrigation fields, water may be supplied to generate the hydraulic power station, and several other reasons. It may be also supplied for domestic purpose. So this is what storage irrigation. Storage irrigation, your objective is to store as much water as possible, and in this case, you can reach to a larger population. Okay, in case of direct irrigation or diversion scheme, what happens is you can reach for only small percentage of population. Here you will reach for a larger population. Like if you see, because of Almaty Dam, almost two districts have been benefited, and the farmers of two districts have been benefited. Now going with combined and diversion scheme. So again, the name itself explains you what is combined storage and diversion scheme. So here we will store the water for the scanty rainfall. Like for example, whenever there is a summer season, so in order to use the water in the summer season, we will decide how much storage is required. Based on that, we will construct a dam, and the water that is stored in the dam will not be used will not be used in case of rainfall period. Okay, so the water that is flowing in the river during the rainfall period will be diverted towards the farm field. Okay, and the storage which has been done will be used in case of non-rainfall period. Okay, so you can see the schematic sketches of this in storage irrigation. As you can clearly say, there is a huge dam which has been constructed. This is the water being pounded, and these are several canal system. So the water is supplied on the right bank canal and left bank canal. Okay, now going with combined storage and diversion, what all things can be done? You can use it for hydroelectric power generation, water supply, flood control, fishery, recreation, and all of those things. Okay, now you can see this is the schematic sketch of combined storage and diversion. So this is a river, so this is the barrage which has been constructed, and the water is pounded here. The water that is stored here will not be used for supplying water in rainfall period. So the water that is been here, the water that is been flowing here will be stopped for some time, and that will be diverted towards the irrigation fields. Like for example, there are no canals connected to this barrier. If you can see here, there are canals connected to this barrier. So this is left bank canal, right bank canal. The water is diverted from this small weir that has been constructed. Okay, this will be used for further use. Okay, right. So this is what the type of irrigation is. So these are some of the things that you must understand. Okay, next is type of soil. As we know, uh, before we understand the requirement of crops, why do we need to understand the requirement of crops? By understanding the requirement of crop, you can decide what is the irrigation requirement. If you understand the irrigation required, based on that you will understand what is the demand of water for irrigation fields. So based on the demand, you will be planning your hydraulic structures or your irrigation system. So that's why first is that we need to understand what are the water requirements. So to understand the water requirements, we need to know what is the type of soil. So you might have two types of soil. One is residual soil, the other one is alluvial soil. So what is residual soil? We all know what is residual soil is. Basically, it is a disintegration of natural rocks, and our India is basically covered by this alluvial soil itself. In most of the northern part of India, the soil is basically alluvial soil itself. So alluvial soil is the deposition from the flowing river, which is silt, sediment, and all of those things. Okay. Now when you see the type of soil, we'll understand the soil structure also. Okay, now you try to understand here, the study that we do in this subject is basically how much water can be stored in the soil or in the root zone of the soil. Okay, uh, soil mechanics is entirely different subject. The soil study that you do for irrigation is entirely different. Okay, in soil mechanics you try to understand the strength of soils. Like for example, you try to define what is the shear strength, what is the consolidation required, and what is the pore pressure, and all of those things, all of those areas you try to attempt to understand. Here we try to understand if there is a crop, if there is a soil, how that soil is beneficial for irrigation requirements or agricultural requirement. So to understand that, there are three type of water that can be stored in a soil. One is gravitational water, capillary water, hygroscopic water. So if before I explain that, I would like to show you that figure. So like, see, this is the figure which will explain you what is your how the water is being stored here. Okay, if I apply a small amount of water to the soil, you can see there is a molecular attraction of the soil particles and the water. So you can see here all these soil particles are attached with water. Okay, the water that is attached to these soil particles, you can see that there is a blue line around the surface of the soil particles. So the water that is stuck to the surface of the soil particles is called as hygroscopic water. Okay, now one thing we need to understand here is, whatever the water that is attached to the soil particles, it cannot be extracted. It is not useful for the crops also. The water cannot be extracted from that surface of the soil. Okay, next is capillary water. Capillary water means what? The water that is stored because of the capillary action in the soil. Okay, then there is gravitational water. If you apply water more than the hygroscopic and capillary water condition, the water starts flowing in the downward direction because of the obvious gravitational force, right? So these are the three levels of water. If you first apply water, it will be stuck to the surface of the soil particles. Again, the water is stored in the root zone because of the capillary action, and if you apply further more water, the water will start flowing in the downward direction because of percolation. Okay, so you must understand that if the water you apply only to this much, it will be attached to the surface and it will be not useful, and if you apply more than this capillary water, the water will flow down into the groundwater, and again it will be not useful. So the optimum supply of water will be above hygroscopic water and below capillary, below the gravitational water. So it means what, you need to maintain your water within the capillary action. Okay, right, then only the water will be useful for your plants. Now going with the permanent wilting point, here going back to this diagram, you can understand that if the water level is less than the capillary water level, okay, and if the water is only with respect to hygroscopic water, so the plants will start wilting because plants doesn't have any water to extract. So because of that, the plants will start wilting. So this is what we call it as permanent wilting point. Okay, so the plants will no longer be having water to extract from the soil, so that amount of water will be called as permanent wilting point. Okay, now here this is what been represented here. This is what saturation we call. In saturation, complete all the pores of the soil will be filled with water, and this is the field capacity. Field capacity is basically the optimum amount or optimum level of water that can be stored. Okay, wilting point means what? Again, you can see the soil particles are attached with water, and the water cannot be extracted from the soil. Okay, this is what wilting point is. Okay, so these are some of the pictures which have been shown to explain you what is saturated condition. If this is 100 gram of soil sample, 40 ml is the water that can be stored in the pore. Now it goes to be a saturated condition because there is no air in it. So when it comes to field capacity, 20 ml is the field capacity. Okay, if you store 20 ml, the water will not flow due to gravity. Water will be retained in the soil itself. Then wilting is 10 ml. So the capacity of water that can be held within the capillary action is only 10 ml. Okay, 20 ml is for field capacity. Wilting will take place even if there is a 10 ml. So only if the water is between 10 ml to 20 ml, then only the water can be extracted by the by the plant, right? So 10 ml is your capacity of water. Now the hygroscopic water is 8 ml, right? So this is the figure which is explaining you how much water is required. If you apply water up to 40 ml, it will be not useful because of the gravitational action. 20 ml of water will get drained off. Okay, so your field capacity is only 20 ml. So if the water level goes beyond the 20 ml, if it reduces beyond the 20 ml, and if it reaches 10 ml, it is your wilting point. Okay, from the wilting point means what? Even if the water 10 ml water is there, it is not useful for the plant. So that is what this diagram is explaining you. Okay, now again the same definition are there: ultimate wilting, limiting moisture conditions. Okay, now let us quickly understand what are the water requirements of crop. And before we understand the water requirements of crop, we must understand what are the factors affecting water requirements. Okay, first is water table. Okay, if the water table is high, because of the capillary action, the water will rise into the root zone and it will be used by the plants. Now climatic condition, you try to understand this. If it's completely hot season, more water will be operated from the field and more losses will take place, and it just reduces the efficiency of water that you are applying to the field. Okay, now type of soil. If the soil is completely porous, what happens is the water drains off from the soil, it quickly percolates, and because of that the water will not be stored in the root zone for a longer time, and which will not be beneficial for your plant. Okay, method of flowing. What is your method of flowing? Based on that also water retention will be decided. Okay, next is intensity of irrigation. How intensive you are applying the water, how frequently you are applying the water. Based on that intensity can be decided. Okay, next coming is ground slope.